So basically this subject will be useful everywhere. First and foremost thing, it will be useful in your further studies. Secondly, it will be useful for your gate examination. And third thing, it will be useful whenever you reach a company and uh, you're going to build some circuits. That time it will be useful. So what is there basically? I think you must have studied before this this symbol. What is this symbol? This is a transistor which has a base, collector and emitter. Three terminals are there. We can call this as NPN transistor, called as BJT, bipolar junction transistor. This BJTs you must have studied previously, but now you will be studying in this subject is mostly the FETs and the circuits related to the FETs. So what is this FET or field effect transistor? I'll give some comparisons also with the BJTs and FETs. So how this and where this is used. First we'll see the construction of FET, field effect transistor. Let us start. Think that we are having some lightly doped N channel, a lightly doped N channel or N channel, that means N type material. So this is lightly doped, that means the doping level of this semiconductor is low. Very few electrons are there in this specimen, which is a semiconductor. And whenever I say lightly doped N-type material, I can also say there are various N-type materials, and basically this is similar to your conductor. What conductor has is the free charge carriers or free electrons. Whether you take it as a copper, aluminium or gold, all these conductors, these are similar to N-type material, but the number of electrons in that is large. That's why we call them as a conductor. Now similar conductor, if I want to make by semiconductors, then I can use N-type material, saying that yes, free charge carriers here are electrons. That's why I call this similar to conductor. So similar to conductor, the only difference is that it has some resistance, and that resistance depends on the doping level. So whenever I call resistance, then we define resistance as R is equal to rho L by A, where rho is the resistivity and resistivity is opposite to the conductivity. Now conductivity again depends on the free charge carriers and all these things. So somehow this conductivity depends on the free charge carriers, which depends on resistivity. Resistivity again is useful whenever you are defining the resistance. So this has some resistance because it is lightly doped specimen. Now if this is a resistance and I give supply across this resistance, a DC power supply, what will happen by giving the supply? So similar to saying that I have a resistor which is connected to a power supply. So what will happen if I connect a resistor to a power supply? Then as per the Ohm's law, V is equal to IR. V is equal to IR. If I go on changing the voltage, my current will change but resistance will remain constant. This is what the Ohm's law says. So if I want to plot a graph of voltage versus current, then this graph will be a straight line passing through 0. Why 0? Because when voltage is 0, current flowing through this circuit will also be 0. So V is equal to IR, and the slope is given by the, or depending on the resistance R. So normally given by 1 upon R. So this is what is a simple conductor or Ohm's law, which is used while defining the simple circuit of resistance and voltage. Same case will be here for this N type of material. You will be getting the similar graph passing through the 0, because when voltage is not there, there will not be any current flowing through this specimen. So how the current will be flowing? These are the free charge carriers, though they are in minority, although they are in low quantity, This free charge carriers, which are electrons, because of this force of positive and negative, these electrons will start to flow towards the positive side because they get attracted to the positive potential and they get pushed away from the negative potential. So there will be a charge carrier which will be flowing, and because of this charge carrier there will be a current. So normally the current direction is given according to the flow of holes and opposite to the flow of electrons. So as we have applied V, there will be a current flow, and this current flow will be from positive to negative, which will be opposite to the flow of electrons in the specimen, which is an N-type material. So these electrons are sourced from this point and drained out or taken out from this point. So this point or this terminal we call it as a source, whereas this terminal we call it as a drain. So remember this, drain and source terminals. So simple Ohm's law, which is following the Ohm's law, Ohm's law, and secondly it has some characteristics depending on V and I. If you increase the resistance, then what will happen to this graph? This graph will be more horizontal as you go on increasing the resistance. If the resistance is decreased, this graph will be more vertical. So what it shows, you can say that for some specific V, voltage V, constant to all, so you can find when the resistance is very large, very less current flows. If the resistance is increased, the current will go on increasing and go on increasing. So as resistance is decreased, the graph of V and I characteristics will become more and more straighter. So this is what the characteristics you will be finding if you go on changing the resistance. But currently to this specimen we are not changing the resistance. Again, this resistance depends on the doping level. So let us make some changes to this. Now what we have got, a specimen which has drain, source and lightly doped material, where once the supply is given, there will be a current flow which will be because of the movement of the charge carriers, and which will be, this charge carriers are electrons and will be moving from source to drain. So this is what the specimen says. Now we'll make some changes to that. What we'll be making to the changes to this, again I'll take the specimen. In this specimen, which is lightly doped N-type material, which has now two terminals, what we have seen just now. One is called as drain, the other one is called as source. Again giving supply across this, and the changes what we'll be doing here is that we'll be having some heavily doped P-type material. This is a heavily doped P-type material. So whenever there is a heavily doped P-type material, P and P, whereas this is N, and there is a junction, or we call it as a depletion layer, will be formed in this area. Just because of a P-N junction, there will be a depletion layer. Now this depletion layer, irrespective of whatever voltage you give, if you don't give voltage, there will be always a depletion region between P and N junction, that you know from the diode working. So there will be a depletion layer, and this depletion layer will be more in N-type material. Why? Because we say depletion region is always a more, depletion region is always more in low doped area. Now what is low doped area here? Low doped area is N-type material, whereas heavily doped area is a P-type material. So because of this P-N junction, there will be a depletion layer, and this depletion layer will be more in N-type region. So this is what we have called, and we'll be giving some terminal to this specimen, and we call this terminal as a gate. This P-type material, both of them, this is a cross section, let us say. So it is now called as a gate. So we are given some supply between drain and source, and this gate, what we'll do with this gate, we'll connect this gate to the source terminal. There is a third terminal called as gate, and we are connecting that to a source terminal. Again, now we'll start changing the voltage across drain to source. Now what will happen by changing the voltage V? As you know, as we are seeing here in the upper circuit also, if I go on changing the voltage, there will be change in the current. As voltage is increased, current will increase as per the Ohm's law, and we have got this type of graphs because of the V and I characteristics. Secondly, we have not changed any voltage and current in this circuit, so we'll try doing that too. So instead of doing this, we'll be finding out what will happen here. So there will be electrons here. Now these electrons again are in the same force of repulsion. These electrons will be attracted towards positive, repelled from negative. There will be flow of electrons, or now normally we call flow of charge carriers. Because of that, there will be a current. Second thing, which what will happen here is, so it is following Ohm's law, V is equal to IR. So according to that formula, hold on.